Hello everyone, I'm myself PoornaChandra from Mechanical Department, Global Academy of Technology. So today we'll discuss projection of solids. Under that we shall discuss square pyramid. So what is meant by square pyramid? So square pyramid consists of a square base, and from midpoint of the square, if you project center axis, then it will be the apex. So if we join apex to all corners of the square corners, so we get a square pyramid. So as you can see here, so it consists of center axis, the base, and apex, and this face is known as triangular face, and this is known as slant edge. Okay, and this is the base portion, and this is edge of the base, and this is corner of the base. So this is what the square prism look like. Next, if you consider different types of prisms or pyramids, square pyramid look like. So different types of pyramids, if you consider, so we have a triangular pyramid, square pyramid, rectangular pyramid, pentagon pyramid, hexagon pyramid, octagonal pyramid. So depending upon the base structure, so the pyramid varies, right? So now we shall discuss problem number 2 in pyramids. So this is what the square pyramid. So we have a square base, and if you join all corners to the apex, so we get a square pyramid. Okay. So here we have the slant edge. It's called slant edge. It's called slant triangular face. So you can follow the triangle OAB is a triangle formed, and the slant edge is only OC is a triangular face edge. Okay. So now this problem states like this: a square pyramid, 35 mm sides of base and 60 mm axis length, rest on HP on one of its corner corner of the base. Draw the projection of the prism. Sorry, it should be pyramid. Draw the position of the pyramid when the axis is inclined to HP at 40 degree and VP at 30 degree. So here first of all we need to draw a square pyramid. So base will be a square, and we need to draw the pyramid, right? So later it is 60 degree in axis length, and then is given axis inclined to HP. Second is HP inclination we want. It is 40 degree to HP, and last we told axis inclined to VP at 30 degree. So when it tells axis inclined to VP, we are supposed to do beta angle method. Okay. So we shall start solving this problem. So first I will draw a square. So the top view, the dimension given as 35 mm. So we can go for 35, 35. So since it is resting on one of its corners, so I can give angle as 45 degree. So I get corner resting here. So I will just click it here. Next, one more thing you need to analyze when you watch from top here. So all these slant edges will be visible from the top. So I need to join this with visible line. But in prism we need to join with the projection line. But in pyramid, you are supposed to join this with visible line. See now, if you watch from top, so you're able to watch this slant triangular faces 1, 2, 3, 4. These are triangular faces which are visible from the top, and we have the base, right? So this we need to name this. So before that I will do dimensioning for this 35. Okay, now we shall do naming for this. So here we have only one base, but in prisms we had two top face and bottom face. Here we have only one base, bottom face. So that is A, B, C, D, O1 and O, that's all. So here A, I can type A over here. This I can take it as B, this we can take it as C, and this we can take it as D. Okay, but here we have O which is visible from the top, but O1 not visible. So O1. Watch from top, O is visible, but O1 is not visible. All right. So this is how, this is what the top view is done. So square pyramid resting on HP, one of its corners. This is the resting corner A. Okay. If you want, I will type that. I'll show you for your reference it is. So this is nothing but the resting corner. Right side is the resting part, resting corner. So it is resting on corner A. Okay. So now when you watch from front, how it look like that we need to draw. First I'll project this upwards. Okay, I projected this. So from center I need to project it with the axis length of 60 mm. So what I will do, I'll go with center axis and then I'll project it for height of 60. Enter, enter. Right. So now this height should be the apex or axis height. Right. So now if you watch from front, it look like a triangle. OAB triangle is visible from front. The D and C is not visible, which is behind. So what I will do right now here, I'll go with visible line. So I will join this. So it looks like a triangle. So 1, 2, and 3. Right. Now we shall name this first. So this is A. Here it is A dash. Nothing else is there. Here this is C dash. But now if you watch from down, here we are able to watch this OB also visible. B visible, D not visible. So this should be B dash bracket D dash. Okay. And this is O dash, which is always visible, but this O1 is not visible. So put O1 dash in bracket. Okay. So this much is done. But the center axis is not visible here because what from down since this corner is thing, this B slanted is visible. OB slanted is visible. So what I need to do, I need to draw visible line from this. So we need to draw visible line from here. I can show dimension for this, right? So this is what the first position, triangular square pyramid resting on HP, one of its corners, it is resting corner A. So top view we get square resting corner, then front view it look like a triangle. O dash, A dash, C dash is a visible thing, right? That's how we are doing here. So now, so A dash here, C dash is here, so B and D is here, right? Since it's resting on corner, this is the front view here. The front view actually comes this side, not that. So front view will be somewhere here, not this direction. So it will come in this direction. Okay. So this is what the front view. So watch from front, you are able to watch this as a triangle. AC and O. AC and O, right? So the first position is done. Now second position, he has asked us is HP is first position, second position should be HP only. HP, VP. So HP, what I need to do now, it is inclined to, axis inclined to HP at 40 degree as told. So axis is over here, O dash, O1 dash. But I cannot rotate this for 40 degree easily because here we have the slant edges. I can't rotate this. In Prism, all were parallel to each other. I was able to rotate the last edge. But here, only the center axis uh, is in the 90 degree perpendicular, but other two slant edges are slant in nature. We can't rotate this for 40 degree. So what we shall do, we shall rotate the base for 40 degree. We shall rotate the base for 40 degree. Okay. So rotate the base for 40 degree. Okay. So what you need to do? So select visible line. So now from here, since if I want to rotate this base for 40 degree, the angle what you need to take is, I'll just type here HP inclination. Inclination, you are supposed to take it as 90 degree minus given HP angle, that is 40. So you get the 50 degree, right? So that is HP base inclination, okay? So the base inclination you are supposed to take as a 90 minus 40, it is 50 degree. That is, I need to rotate the base A dash C dash for 50 degree, then I will get axis as 40 degree. Okay. So what I will do, first I need this dimension. So we can take this dimension. So it is 49.5. Okay. 49.5. Now we shall draw a visible line here. So I'm going to draw a visible line. So here it is length of 49.5, that length, and angle, as I said, 90 minus 40 degree. I want axis 40. So since I'm rotating the base, I need to take 90 minus 40 degree. I need to take angle as 50 degree. So here, so 50 means it is actually 180 minus 50, right? So we shall do that. So this length of 49.5, enter. So angle is 180 minus 50, right? So now if you check this angle here to here, this should be 50 for us, right? So while drawing, what you need to do, so project a line for 50 degree from this side. This will be the base part. Okay. So actually this will be now A dash, and this will be C dash. Okay. C dash. So this I have drawn right now for 50 degree. Next, what I need to do, I need to project this and I need to draw. So what you can do, you can draw perpendicular line, you can take midpoint of this and you can draw perpendicular line and you can join. Or else what you can do, you can measure this length and you can cut arc. You can measure A dash, O dash from here while constructing. You can cut arc from here and here. That's one method. Or one more method is from the midpoint of this, you can draw 90 degree line for length of 60. Length 60, you can draw perpendicular line. Okay, you can draw a perpendicular line for length 60. Then I can join this to this and we can join this to this. Right? This is how you're supposed to do. Now if you check out angle, so here comes the center axis. Now if you check this angle is 40 degree, right? So that angle is 40 degree. This is what required for us. You want angle 40 degree. So here if you want, you can project it with projection line. This axis you can project with projection line, and that you can show as 40 degree, right? So now we shall continue the naming. So this is O dash, no changes in the naming. This is here comes B dash, bracket D dash, okay, and here comes bracket, sorry, bracket O1 dash. No changes in naming of this, okay. Just watch, I'll repeat again what we did here. So here what I did is, so in order to rotate the axis for 40 degree, so it is difficult to rotate the axis 40 degree while constructing. So what we can do is we can rotate the base itself for 50 degree. Okay. So what I can do, why 50 degree? Because 90 minus 40 if I take, so given HP inclination is 40 degree. So if I want 40 degree, see this is 90. 90 minus 50, I get 40. So if I want to incline the base, then I need to take 90 minus 40 given angle, I will get 50 degree. So that 50 I need to rotate here. So draw line for 50 degree, then measure this A dash, C dash, cut it. Okay. Then you can measure this A dash, O dash in your compass, and from A dash you can cut arc here. From C dash you can cut arc then join that, then join this to midpoint of this. So your job is done, right? Next, so how it will look from top view? So we need to draw the top view here. So we shall project this downwards. So I have A, first I'll project this point A is done, and I have C till here itself, C is done. Next B will come somewhere here, you can just join. So you can just project as usual, trim this. So you get A, B, C, D, but we have point O, which comes again here itself, you can join this. So first we shall do naming for this. So compared to prism, pyramid is quite simple. You can understand and do easily. C and D. So name for respective points. And here we have O1, it is not visible from top. Directly I will type it as in bracket. Okay. So this is done. Now which are the edges visible? We shall understand and we shall start joining with visible line. So what you need to watch from top. Okay. So if you watch from top here, so as you can see clearly, this OC is clearly visible from top. So join OC first. So O and C is visible. Done. Next, which is a visible edge. So watch from top, this O dash, B dash, OB and OD. So it's actually at center. So you feel that it is not visible from top. But if you watch here, it is outer edge. OB and OD, it should be visible. It can't be hidden. OB and OD. It must be visible. And again, this DC and DB. Outer edge should always be visible. So we have all visible lines. OB, OD, and OC is done. Then which is not visible? So here we left out with A. So A naming I have left out. This is A. But if watch from top, A is not visible. So we can keep point corner A in bracket. Okay. So the thing which are linked with A is not visible. OA is not visible, but OA is overlapped with OC. So we can't do anything. It is should be visible itself. But actually it was not visible. And one more thing, this AB and AD is completely at bottom portion is not visible. So that I can show in hidden line. So that we need to show with hidden line. So select hidden line and mark this AD and AB. Okay. This one is somewhere here. Okay. So now the second position is done. So if you watch from top, OC visible, joined OC first. Next OB, OD, since outer edge is visible, OD, OB. Then this BC, DC. So BC, DC also visible outer edges. So the one which is not visible is OA, but here OA overlapped with OC, we can't do anything. First reference for visible line. Next AB, AD, it is hidden line. So this completes the second position, right? So triangular, square pyramid resting on one of its corners, projected up 60 degree. Then we rotated the axis for 40 degree. This is the axis rotation, 40 degree. Okay, and then so this is 40 degree. Okay, and then we projected downwards, and we got it like this, right? Next, third position, what I need to do? The third condition given, that is VP condition. So it is inclined to VP at 30 degree. So inclined to VP at 30 degree. So we need to rotate this for 30 degree. The axis inclined to VP as told. So we are supposed to do beta angle method. So beta angle method, we need to take two axis dimensions. So here in first position, O1, we have 60 mm, and second position, we should select this distance between and select distance between this and this. So measure O1 length in second position. So here O1 length is 45.96. So that we need to use. So we shall start drawing this. First select projection line and draw a line this side for axis inclination and axis appears method. So draw uh, the line over this side. So given angle as 30 degree. So we need to length I will take around 100 mm. So angle we need to take 100 plus 30. Sorry, 180 plus 30 degree. So I get here. So for confirmation, you can check the angle here. It is 30 degree, right? I can take 180 plus 30 or 180 minus 30. Both will come here itself. So any angle you can choose. Now what I need to do, I need to construct this over here with beta angle method. So first angle length I need to take this 60 mm. So I will go for center point arc method. Arc by center point. So we'll start from here. The point O will come here, here, and length is 60. Type 60 arc radius. Enter and cut arc like this. Okay. So I have cut arc here. Then what I will do, I will trim this one of the end. Okay. Then in order to find the locus of point O, we shall draw a projection line here like this. Okay. So first draw arc for 60 radius. Okay. So this arc for 60 radius. Next arc we need to draw. Cut this locus of O. This will be O1 or you shall write it as O2. Okay, for our reference. Next, I need to cut one more arc for length of this O1 length is 45.96. So again, select arc by center point method. You touch this arc, you get this resting point. See, if I touch this, I get this the first position, first arc point. Then I can type it as 45.96. Enter. Now we can cut one more arc like this. Okay. Then we can trim this further. Now what I can do, I can join this with this, right? So this arc radius you can show there. This arc is 45.96. Okay. So now I have projected this. Now what I need to do, I need to extend this line till the horizontal line. Then I can measure the beta angle between this and this. So I'm getting beta angle as 41 degree. Okay. So beta angle I'm getting as 41 degree. Now you can type the angle as beta angle is equal to 41 here. Beta angle is equal to 41 degree. Okay. So now I have projected this. So now what I need to do, I need to construct this over here. So now this is O1 point. Okay, O1 and this point as stated is O. O and O1 is ready right now. These two. Now we need to construct this over here. Our construction, what you can do is O1 is perpendicular to this O1. This O1D, O1B is perpendicular to this. So you can draw perpendicular line for this line, perpendicular line this side. Okay. So that what you can do, you can draw a line from here perpendicular to, 1 second, you can draw perpendicular to this and then you can measure this O1D and cut it both sides, and you can join. That is one of the method. So here what I will do, I will select this, okay, and I will move this with copy. With copy, I will select this as a point. So if I touch the arc, I get this point here. Left click, right click. Then we can tell rotate without copy. Again, click on the same point. Then click anywhere on this. So rotate and can place on this line. So you can check out this how it has came. So you can rotate and you can keep. Okay. So now I have O1 here. So O is here. So we have projected and it is done. So while constructing in the book, so what you can do is so while construction, so after finishing this O1, so you can draw perpendicular line from here from O1 perpendicular to this O1 line. So you can then measure O1D and cut arc both sides. Okay. Then you can join this directly. Then extend this line down backwards, measure O1C and cut downwards, and then join these two. So then the third position will be done. Okay. So now the third position is done. Yeah. So third position is done. Next, I need to project up and join. So we shall project it upwards. So I will go with the projection line. See now A dash is on XY line. Project A till XY line. Done. Next, B and D. So B is coming here and D on this line. Next C. C somewhere here. Yes, we can join this directly. So project everything. Then we can name this first to avoid confusions. This is C dash and this is D dash and this is B dash. Okay. And this is A dash. So all four are done. Next, we need to project. So this is a point O dash. Okay. Point O dash. And we have one more O1 dash. So O1 also will come on this line itself. So I can project it. Okay. Now I can name this. This is O dash, right? So now this is done. Yes. Now if we check out this, so which are the visible edges? So we can select visible line. Here, since the base portion is down and observer is somewhere here, right? Here always the observer lies. So observer is watching from this direction. Okay. So now for observer, the base portion here is completely visible. That is A, B, C, D is clearly visible. So first I can join this A dash, B dash, C dash, D dash without any confusion. So the base is visible. So first we shall join this base portion. This is done, right? Next, which are the visible edges? So as we did in prisms, the topmost edges which are near to the apex are first visible. So here I can join this C dash, O dash, O dash, B dash. And finally, if you check out this, O dash, A dash is coming outside, which is outer part from B. So it should be visible. So it is coming right side of B. So here B dash we have somewhere here. Okay. So this O dash, A dash is also visible clearly, right? So this is how it looks like. Then I need to draw the center axis from O1 to O, right? But this O1, since base completely visible, O1 is also visible. So I can name it as O1 dash. Okay. So now, if you check out, this is how the problem ends. So here we have, so since the base visible, I have joined base ABCD first. Next, so if you watch carefully, the OB visible, okay, OB visible, I have done OC visible, but OD is far away from the observer. So that OD is not visible. So I need to draw hidden line from O and D. Okay. So that will complete the problem. Right. So again, if you analyze this, so we have a square pyramid resting on HP, one of its corners, resting corner A. The same A came at the end. You can watch here. It is lying on corner A only, not other corners, right? That's why we can tell that the right side is the resting corner. So then project up, it look like a triangle in the front view. So draw triangle and name it as like this. Then it is inclined to HP at 40 degree as given. So since we are rotating the base, so you incline the base for 90 minus 40 degree, that is 50 degree. So and construct this, then project down and construct this. Then you can incline it for 30 degree. We told axis inclined to VP at 30 degrees. So you need to do bit angle method. So draw bit angle, draw 30-degree line, then measure this O1, cut arc, then draw locus of O, then measure this length O1. This O1 is in bracket. Okay. So O1, then you can project this up. Okay. So project up and join that. So construction of this, once you get O1 line, so project it, draw perpendicular line for O1. You can mark D and B with compass, measuring this length. Then project downwards, measure O1C and cut it. Then construct this picture. Then project up and join. So base visible, join base first. Then upper slant edges are first visible. Join OC dash, O dash B dash. Then check for O dash A dash. If it is outside, it should be visible. If it is inside, it is hidden. So O dash A dash, but hidden one is O dash D dash, since it is near to XY and far away from the observer, right? So this is how the problem will be solved in projection of solids, and that too a square pyramid. It's problem number 2. So I think you understood this. Thank you.